Hello friends, welcome to my channel. Let's have a look at problem 1657. Determine if two strings are close. In this video, we're going to share a solution based on the consideration of the unique letter frequency distribution. First, I'll read through the problem statement to digest the task, and then we do the coding. In between, we do the explanation. So first, the problem statement. Two strings are considered close if you can attain one from the other using the following operations. Operation 1, swap any two existing characters. So this operation tells us that the positions of the letters are not important. So the second operation is the following. We can transform every occurrence of one existing character into another existing character and do the same with the other character. So for example, here A appears 3 times and B appears twice. So you can change to B appears 3 times and A appears twice. So this problem tells us that the frequencies are the important things. So we can use the operations on either string as many times as necessary, right? So I would say, we need to take into consideration of this sentence in order to see the relative positions are not important and the important things are the frequencies. So given two strings, word 1 and word 2, return true if they are close in the sense above and false otherwise. So here are several examples. So let's look at example 1. So example 1 is a permutation of the one word. For example, word 2 is a permutation of word 1. So vice versa. So the return should be true. So in the second example, so the lengths are not the same. So they are not close. So in example 3, so the return is true. So here A appears twice, B appears 3 times, and C appears once. So frequencies are 1 to 3. So in word 2, A appears once, and B appears twice, and C appears 3 times. So the frequencies are still 1 to 3 respectively. So in other words, in example 3, so we see that the frequency distributions are the same. So this should return true. So before we do the analysis, let's look at the constraints. First, the length of the word 1 and word 2 are in between 1 and 10 to the power 5. However, this is not the problem does not guarantee word 1 and word 2 have the same length. So the second constraint is that the word 1 and word 2 contain only lowercase English letters, right? So with that said, so we can look at the method. So as when we went through the 3 examples, we noticed that so we need just compare the unique letter frequency distributions, right? So once we get the frequency distributions, then the problem is straightforward. So however, there's one thing we need to notice. That is, we need the set of unique characters in each word is the same, right? For example, ABB and CDD, so they have the same unique letter frequency distribution, but the unique letters does not match, right? So this example here should return false. So with that explanation done, so we are ready to write the code. So actually, the code can be written in a one line. So, but let's write with some redundancy to explain the idea. So first, I want to get the frequencies. So let's use counter word 1. So we can do the same for the second word. Let me copy this one and use this word 2. And then we want to get the frequency distribution. So in order to compare. So but here the order, so we need just do a sort, right? So this will be easier. So sorted count 1 values. So the values are the frequencies. So similarly, sorted count 2 values. So we want to return if v1 equals v2 as a list, or it can be regarded as a vector. So, however, this missed one thing, that is a note. So we need to make sure first, as a set, so word 1 equals set word 2. So in other words, they have the same set of unique characters. So this forms a full solution to this problem. Let's do a check. Yeah, it passes this one. So let's look at, you can check for the 3 example here. So now let's look at the generic case. Yeah, it passes all the all the generic cases. So in my first several tries, so I forgot this condition. So it returns a wrong answer. So it also indicates that this is very important. So in other words, so a sufficient condition, a necessary and sufficient condition for two words, word 1 and word 2, to be close in the sense of this problem is that, so set word 1 equals set word 2. So this tells us they have the same unique characters. Add the following. So the unique letter frequency distribution is the same. So here, this is using set language. So here we're using this is actually probability mass function if we interpret as in using some probability terminology. So with that said, I guess that's about it for today's daily challenge problem. So thank you very much.